So let's get this training started, all right? Good afternoon, Asia, and good morning, EMEA. Thank you for making it to our training today. This training will be largely focused on the new features on aCloud 5.807R1 and ACMP 5.8.6R1. For those of you who haven't heard of our aCloud and ACMP before, I'd like to give you guys a very brief introduction to the aCloud and ACMP product. aCloud actually is a rename of our HCI product, okay? And aCloud is more focused on the infrastructure side. ACMP is a component that is able to be run on aCloud to turn aCloud into a cloud, a private cloud at the moment. And you can see that the version numbers of these two components actually are different because they are being developed in different directions. Like I said, aCloud is more focused on virtualized infrastructure like compute, storage, networking, and security. ACMP is the cloud management platform that can turn those virtualized resources into a more orchestrated and automated cloud environment. And there will be some new features that are available on aCloud and some new features that are only available when you install ACMP on aCloud. So let's get this cleared first. And an overview of what's new on the new version. First, we've added stretched cluster for active data center. So now customers can deploy active solution with our aCloud. We know that ever since 5.806, we added disaster recovery orchestration and management on the aCloud platform so that the customer can have a very high level of protection for their business. The RPO can be as minimum as 1 second if the environment is good enough. And the RTO can be, several minutes. After stretched cluster, the RPO can be reduced to 0. That means actually there will be no data loss if customer deploy stretched cluster for their business. And the RTO can also be minimized to several minutes. We will dive deeper in the coming slides for stretched cluster. And the next feature we added on 5.807R1 is GPU support. We now can support NVIDIA GPU. And we can support two modes, pass-through and VGPU solution. We are collaborating with NVIDIA to make this solution possible. And with the GPU support, we've added new scenarios for our aCloud. Like now we can support graphics intensive applications like GIS, like a video transcoding, and also customers can train their deep learning workloads on the aCloud platform. There are tons of new features on the new version. We've added reporting for ACMP. So now customers can export reports of the resource usage status of specified VMs and hosts. And they can view that reports from different angles, like the CPU, the memory, usage, latency of the application's access time. So lots of information can be collected and exported from this reporting feature. Seed backup is a complementary feature for disaster recovery. With seed backup, customer who has a very narrow bandwidth between different sites, between their production and DR sites, now can use this seed backup to export their data at the first time to a portable disk or to even a USB drive, and then they can transport that media physically to the secondary site to upload the data directly to the secondary site. This will save a lot of time for the first time for backup. Now let's take a look at stretched cluster and GPU support in a deeper perspective. First is stretched cluster. This is a feature we implemented on aCloud 5.807 R1. So it's more infrastructure focused. It's not a feature that is implemented on aCMP. And what is a stretched cluster? Basically, you can consider a stretched cluster a single cluster. The difference between stretched cluster and the traditional cluster is that the stretched cluster is located at two different sites. Okay, basically you are extending our aCloud cluster from a single data site to two sites for more higher level availability. And typically, customers who have this kind of requirement, we need an active data center solution to ensure the business continuity for their mission critical applications. And there are some restrictions for stretched cluster because the bandwidth between two sites when you deploy stretched cluster is need to be very high. You gotta have a very high bandwidth between those two sites. Usually there should be bell fiber connection between these two sites, and also there will be a witness site to do the arbitration. And with a witness site, split brain situation can be avoided. This is from this slide. You can see that the topology is a typical vSAN stretched cluster from VMware, and for aCloud stretched cluster, the topology and the design philosophy remain the same. So what scenarios can we apply stretched cluster to? There are two major scenarios you can use stretched cluster. One is planned maintenance. Usually stretched cluster is an active data center solution. That means even though you lose one site, you can still have your applications running without any interruption if that application can support active mode. So you can have this one site shut down for maintenance but still have your applications running without disruption. And also you can use this solution to propose for the disaster avoidance scenario, because usually the two sites, they are physically isolated with each other. Even one site fails would not affect the overall operation of the cluster. And once one site fails, the ASVHA will restart any VM on the failed site to the other side to make sure that the business can be resumed. And the value of stretched cluster, because it is active data center, and there is shared storage between these two sites. Okay, the storage is a logical storage pool, and it provides shared storage for both sides. So when one site fails, the other side will still have the copy of the failed site's VM's data. That means even one site fails down, the data will not be lost. The RPO will be 0. For the RTO, if the applications can support active mode, such as Oracle Rack, if customer deploys Oracle Rack on our stretched cluster, the RTO can be made 0, because the Oracle VMs will be running simultaneously on the two sides, and they will write to the shared storage and read from the shared storage. There is a very strong consistency between these two sides. Even one side fails, the other sides will take over the business seamlessly. So there will be no business downtime and there will be no data loss. Keep in mind that stretched cluster can achieve a 0 data loss, 0 business downtime protection for customers' mission-critical applications. And for SandForce aCloud stretched cluster, we can start with 4 nodes. That means 2 nodes at each side to construct this stretched cluster. It starts small and you can scale big. The maximum cluster size can be as big as 24 nodes. That means each side will have 12 nodes. Take a deeper look at our stretched cluster solution based on aCloud. So basically, there will be 3 sides usually, primary side and secondary side. And these 2 sides are connected by bell fiber. And we recommend the bandwidth for this bell fiber should be 10 gigabit per second. And the RTT should be less than 1 millisecond. Okay, this is the very first generation active solution we've come out with. We've come out on aCloud. In the future, we will optimize the bandwidth requirement. But for now, the bandwidth is kind of stringent. The bandwidth requirement is kind of stringent. 10 gigabit per second bell fiber for large-scale deployment. If the deployment is relatively small, such as 4 to 6 nodes, that means 2 to 3 nodes at each side, then we can also support 1 gigabit per second bandwidth. And there is a third side for witness node. The best practice is to put the witness node at a third side that is physically isolated from the other 2 sides. But realistically speaking, for some customers, they don't have 3 sides. In that particular case, the witness node can also be installed maybe in another building or at another floor that is separated from the primary side and secondary side. And for the bandwidth between witness node and the production node is that we recommend customer to deploy at least 100 megabit per second bandwidth between witness and production. The latency, the best should be less than 1 millisecond, but we can tolerate fluctuation within 5 milliseconds. So you can see the bandwidth, the network bandwidth requirement for stretched cluster, no matter is the 2 production sides or the witness sides, is quite high. Okay, it's quite stringent. We gotta have bell fiber connection, and the latency should be restricted as minimum as 1 millisecond to be best practice. And for the deployment scale, we can, like I said, we can start with 4 nodes. That means 2 nodes at each side. And also, we can scale out to 24 nodes, 12 nodes at each side. Currently, we can only support 1 virtual volume that is stretched across 2 sides. The scenarios that we will propose the stretched cluster at this stage is, first, different floors inside the same building, and then 2 adjacent buildings, 2 buildings side by side. They are very close with each other, and they're connected with fiber, dedicated fiber. And the last one is 2 server rooms that are located inside the same campus. Okay, the distance cannot be too far, because we have a stringent requirement for latency and bandwidth. And you cannot fight physics, right? When the 2 sides are too far away from each other, the latency will be larger. And when you introduce more latency, you cannot realize a perfect stretched cluster active solution. But like I said, this is what we have now. It's just the beginning. We will keep optimizing stretched cluster based on aCloud. Within this year, we are going to support metropolitan active. That means we will be supporting, deploying stretched cluster inside 1 city. maybe dozens of kilometers between two sites. For that situation, we will be supporting in the coming months. And we will also be supporting 3 centers across 2 sites, complementing with our disaster recovery. Okay, customer who has a very high requirement for business continuity and data integrity, they can use stretched cluster and our disaster recovery for a higher level protection for their business. Maybe inside one city they can deploy stretched cluster, and then in another city they can have a third data center, and they can use our disaster recovery for the third site protection. Basically, with the stretched cluster, you will achieve business active and data active. For business active, this situation will require the support from applications such as Oracle RAG, because if you want to achieve business active based on stretched cluster, the 2 sites, the applications must support active deployment mode. In this case, you can see that Oracle 1 and Oracle 2, these 2 Oracle database VMs, they have to be running concurrently, and they need to provide the same kind of service for outsiders. And when one site fails, let's say the primary fault domain fails, the Oracle 2 VM will take over the business without any interruption. Okay, the RTO can be made as minimum as 0. But because business active requires the support from applications must support active deployment mode. Otherwise there will not be business active. There's only data active. With data active, it can support all kinds of applications. Basically, no matter is traditional applications or active applications, data active can be easily achieved. In this case, the app is running on the primary site, and when the primary site fails, when some unexpected accident occurs, such as a fire or lightning strike, whatever, this primary site fails, actually a high availability will kick in to reboot this application, to reboot this VM on the secondary fault domain. In that case, the RTO will be minutes. Okay, the RTO will be the reboot time of that failed VM. But for the RPO, because stretched cluster has the virtual volume that is stretched across 2 fault domains, so there will be no data loss. Just like consider these 2 sites as a single logical cluster. So when the app fails, the VM fails, it will be rebooted on the secondary fault domain to resume your business. For the data active solution, it is very easy to achieve. There's no specific requirement for applications. So it has much lower complexity compared to the business active solution. Business active solution has superior RTO, which is 0 compared to data active, but it will introduce more complexity and more cost because it requires applications to support active. So with stretched cluster, we are going to introduce a new license, which is called ASC. And ASC is based on, it's the same like ASV and aSAN. It is based on the number of physical CPU sockets in the stretched cluster. And to use ASC, customers must purchase ASV and aSAN in advance, because stretched cluster requires shared storage, and the shared storage can be made with aSAN. Let's have a look at the example of licensing. From scenario 1, it is a typical scenario that the customer has 2 clusters. one traditional cluster with 40 CPU sockets, and one stretched cluster. In this particular case, the aSC license will be 20 because customer only has a stretched cluster with 20 physical CPU sockets, right? So the aSC is 20, and because aSC also requires ASV and aSAN to function, so it has to be there has to be 20 ASV and aSAN for that stretched cluster. Take a look at scenario 2. Scenario 2 is a phased construction scenario. So customer maybe at first phase they purchase an aCloud cluster for their production workloads, and then maybe the application is really important. The applications they are running in the aCloud cluster are very important. They cannot tolerate any downtime or cannot tolerate any data loss in the event of this production side failure. So on the phase 2, they are going to construct another data center, at a different site, and the other site will have another 20 CPUs of nodes, and they want to build a stretched cluster across these two sites. So site 1 has 20 CPUs and site 2 has 20 CPUs. Then the total licenses for aSC will be 20 plus 20, 40. And ASV aSAN also need 40 CPUs of license to function. Let's have a look at a typical use case of aCloud stretched cluster. This use case actually originates from a real case from domestic China market. Okay, it's a newspaper customer. They have the requirement for stretched cluster because they have 2 server rooms at 2 different floors, and one of the server rooms has better equipment. It has newer servers, newer storage, newer network switches, and they have different workloads running on these 2 server rooms concurrently. And the customer wants to build an active data center across these 2 server rooms, and they also want to run some of their more important workloads on the new server room, which has better equipment, better devices. Okay, in that particular case, aSAN for aCloud stretched cluster is the perfect solution for them. Simply deploy aCloud clusters, simply deploy aCloud nodes at these 2 sites, and then build a stretched cluster with these 2 server rooms. And because the stretched cluster has 4 domains, so basically one server room is a 4 domain, and we can specify the VMs running in one 4 domain as a preferred running location, so that when that 4 domain fails, the HA will reboot that VMs on the other healthy 4 domain. And like we introduced, there are 3 typical scenarios for our stretched cluster. First is, within the same building, the server rooms are located at 2 different floors. And the next one is, 2 buildings which are side by side. They are adjacent from each other, and customer has 2 server rooms in these 2 buildings. They can deploy a stretched cluster solution across these 2 buildings. And the last one is 2 server rooms at 2 buildings inside one campus. Maybe these 2 buildings are several hundred kilometers from each other, and they're connected by dark fiber, bell fiber with maybe like 10 gigabit per second bandwidth. In these 3 cases, stretched cluster can be a suitable solution to achieve a higher level of availability for customers' mission-critical applications. Okay, here comes one polling question for all of you. because stretch cluster can provide higher availability and higher level protection for customers' mission critical applications. Let's see if you guys have ever encountered any requirement for active data solution. And please choose, select the answer based on your experience or based on your future requirements. We'll give you, 10 more seconds for the polling, and then we'll move on to the next section of this training, which is GPU support. Okay, thank you for your participation. Let's move on to the next session. The next session will be GPU. Okay, if you have ever played 3D games, on your laptop or your, desktop, then you will understand the importance of GPU. Typically in our laptop, we know that there is a central brain, which is called CPU. And the CPU takes care of all the, processing power for the applications in most cases. However, in some particular cases, let's say when you need to run a 3D game, a very graphic intensive 3D game on your laptop, then CPU may not be able to cope with that workload. Or you want to run, some repetitive workload, like, you want to mine the Bitcoin on your laptop. Then CPU, again, is not the ideal component for that workload. GPU is becoming a more and more important component in nowadays computer and nowadays server. A GPU stands for graphics processing unit. It is actually, you can consider it as a dedicated CPU for particular workloads. And there are some characteristics for GPU computing. There are some characteristics for GPU, which is, GPU is suitable for running high concurrency, high density, massive and parallel workloads, such as graphic rendering. When you render a graphic, the GPU has to provide the processing power for those pixels. And there are hundreds of thousands of pixels. And it is a very large batch of data sets. So why is GPU more suitable for that particular workloads? The difference is here, like this picture shows. CPU usually has, multiple cores, and those cores are clocked, between 1 to 4 gigahertz, right? However, the GPU has thousands of cores, and these cores, they are very suitable for those basic mathematical computing. The workload like, video transcoding, like graphic rendering, or, big data analysis. In those scenarios, the workload, it has lots of data, and it doesn't require a very high core to processing the logic in that data. However, it is a very repetitive and highly parallel processing. With GPU, because it has thousands of cores, even though the core on GPU, an individual core on GPU is not as powerful as the core on CPU, but because the quantity of the cores on GPU is way more than the CPU, so it can process the workload, those particular workloads in parallel, concurrently. So the time that it would take to render a picture, to render a video, or render a 3D game will be significantly lower compared to running those workloads on CPU. CPU is ideal for serialized workloads, and the difference between the GPU and the CPU is GPU has more cores, and it is more suitable for repetitive and highly parallel workloads like video render, graphic intensive applications and big data applications. There are some applications in the enterprise section that will require GPU. Examples are GIS, we call it GIS, Geographic Information System, and graphics rendering system. In some enterprise design companies, they need this GPU power to help them render the graphics. There are some, more advanced workloads like AI, artificial intelligence, or machine learning system. Customers can deploy those AI models on the GPU and then use the GPU power to analyze the algorithm and analyze those large batches of data for a more predictive model. There are also some applications such as the computer-aided engineering, CAE. Those applications also require highly intensive graphic processing power to process the 3D model. Scenarios of GPU applications would be like video transcoding and streaming. Even in video surveillance scenarios, sometimes when the camera streams the videos from the front end, those videos will need to be transcoded and streamed on the backend system. In that particular case, GPU power is a necessary element, and also graphics rendering for enterprise design, and also some labs in the education sector, such as in the universities, there are some big data labs or AI labs. They will run those deep learning and big data applications on the data in the data center. In those cases, GPU is definitely an indispensable component. And on this version, we've added the VGPU support in collaboration with NVIDIA. So basically, we've embedded NVIDIA VGPU Manager into our hypervisor, into the aCloud. And the NVIDIA VGPU Manager has the ability to logically partition a physical GPU into multiple VGPUs for multiple VMs to use. And as long as the VMs are installed with NVIDIA driver, then, and also in hardware, there needs to be NVIDIA physical GPU graphics card on that server. And combining with aCloud virtualization platform, we are able to provision the VGPU power to those VMs. In these user scenarios, the GPU can be utilized at a higher level compared to merely using the physical GPU. And also, besides the VGPU solution, we can also support GPU pass-through. That means if you have an NVIDIA GPU card in your server, then with aCloud, you can directly provision the NVIDIA GPU to a VM to use. But the GPU, the physical GPU, will only be used by very few VMs. The resource utilization will not be as high as the VGPU solution. So why do we need to support GPU? Because it's not only about the background we just introduced, that GPU is becoming more and more important in modern applications. But also, managing large amount of GPUs in the data center can be a very big pain point, can be a very big headache for customers. Especially nowadays, servers, storage, and almost all the traditional data center equipments have already been virtualized. But for GPU, if you cannot virtualize GPU, then you will have this virtualization and physical environments sitting side by side, and you have to manage them one by one. This will create silos in your data center, and in return, it will be a waste of resources, and also very difficult to match the resource for your applications. With aCloud VGPU solution, we can virtualize the GPU and provide a visualized GPU resource utilization management for customers to use. They can simplify their GPU deployment and management. And also because the GPU power, the GPU resource, the physical GPU card is virtualized by NVIDIA VGPU Manager, and we can have a GPU resource pooling, and we can intelligently allocate the GPU power, the GPU resource to the VMs in need to maximize the GPU utilization. If you have one M10, NVIDIA M10 card, the M10 card has 4 physical GPU. If you don't have VGPU solution, then you can only provision GPU card for 4 VMs. But with the NVIDIA VGPU, you can partition that M10 GPU card into 24 VGPU cards, and then provision the VGPU cards to 24 VMs. That significantly improves the utilization of the GPU resource. So VGPU comparing to physical GPU, especially in large-scale deployment, the benefits are obvious. When you deploy virtualization and VGPU solution on aCloud, you can have this batch deployment. I can assign VGPU to VMs in batch instead of assigning the resource to VMs one by one, and the utilization can be much higher compared to only using the physical server plus physical GPU, because we've optimized the VGPU solution into our aCloud management portal. So you can have a unified and visualized management for all of your resources running on aCloud, including the compute, storage, networking, security, and also your GPU resources. And with VGPU solution, you can have a much more flexible allocation and distribution of your GPU resources based on your workloads needs. So it has lots of benefits and values for customers who need to utilize GPU in their data center, especially in large scale. And with a new capability, it always comes with a new license. But this license for VGPU doesn't come from Sanford. It comes from NVIDIA. If customer needs to deploy VGPU on aCloud, they want to utilize the GPU virtualization for their GPU applications, then NVIDIA's license is needed. And this license is licensed by the number of concurrent VGPU VMs. The concurrent VGPU VMs stand for the maximum number of the VMs customers are using simultaneously. Let's say if customer has at their peak business peak time, they have 20 VMs that will be utilizing VGPU. Then the license of VGPU for NVIDIA will be 20. Okay. However, sometimes customers, they will have 40 VMs with VGPU, but only at peak time, only 20 VMs will be powered on. In that case, also 20 licenses are needed, not 40. And if customers only utilizes GPU pass-through on aCloud, they only need the pass-through GPU card from NVIDIA to aCloud to their VMs. Then there's no license required. No license from Sanford, no license from NVIDIA. And no matter it's VGPU or GPU pass-through, Sanford doesn't charge for any license for the GPU solution. Okay? And because we are cooperating the GPU solution with NVIDIA, and from NVIDIA side, they will have 3 types of VGPU licenses: VPC, VDWS, and EDU. VPC is usually used in in a maybe like a consumer use scenario. VDWS is the one with the best performance among the between VPC and compared to VPC, and we are reselling VDWS and also EDU license. EDU license is only available for education customers. Okay, if customers from university or from college, they have the requirement for for the VGPU license, then they can buy the EDU license from NVIDIA or from us. We can resell this EDU license. The EDU license has the same features as the VDWS license, but it comes at a much lower price because of this education promotion by NVIDIA. We all know that VGPU was supported long ago by our aDesk VDI solution. And based on that aDesk VDI solution, we've optimized our VGPU solution on aCloud. So there are some differences between VGPU solution on aCloud and aDesk. The differences include the VGPU solution on aCloud can also support the Linux operating system. And as far as I know, our VGPU solution on aDesk can only support Windows. And also you can launch the VM console directly from our web UI. That is also a difference between our aCloud and aDesk VGPU solution. On aCloud, we can support VGPU mode for NVIDIA P40. To my knowledge, aDesk can only support NVIDIA M60 and M10. NVIDIA P40 is more suitable for deep learning workloads. It's more suitable for training, machine learning training. And we've also made some optimization on the UI details. We can visualize the GPU resource management on the aCloud unified management console. Some cautions you need to pay attention, when you are when you are going to use aCloud GPU solution. The first one is that not all servers can support the GPU installation. Okay, not all servers can support the GPU installation. Our previous aServer models like aServer 2000, aServer 2100, all those aServer 2000 series, they cannot support the GPU. They are non-GPU models. If customer has existing GPU servers, then they can reuse their existing GPU. And if customer wants to buy dedicated GPU server from Sanford, then we can provide the aServer G350 and G650. Those two models are our dedicated GPU aServer models. And the second caveat, the second caution that you need to keep in mind is that currently you can only attach or assign one graphics card to a VM. You cannot assign multiple GPU cards to a VM, no matter it's pass-through or VGPU mode. Okay, this was limited by NVIDIA, and I heard that NVIDIA has already lifted up this restriction. Maybe in the future we will also lift the restriction for single graphic card to be attached to a single VM. After the restriction is lifted, we may be able to support multiple graphic cards to a single VM. And here comes the second polling question. Because GPU support again expands our use scenarios. Now we can support applications with GPU requirements like GIS, like graphic intensive or big data and machine learning workloads. So have you ever encountered any scenarios for the GPU solutions? or what type of workloads are those applications requiring for. Please select the option based on your experience or your upcoming requirement. And I thank you for your feedback. We'll give you 10 more seconds for the polling, and then we will move on. Basically, GPU and stretch cluster are the two major updates for aCloud 5.8.7 R1. And in the coming slides, we will introduce some of the minor optimizations on the platform. Okay, let's move on. Seed backup. This is a complementary feature for our disaster recovery solution. You know that disaster recovery solution was released on 5.8.6, and it is based on a local backup and offsite replication disaster recovery solution. So when customer build a DR solution with our aCloud, there will be local backup at the primary site, and then the DR module will transfer the data to the secondary site over the wire. But for the first time, the backup is a full-time backup. And if customer doesn't have a relatively wide bandwidth between the two sides, the transmission time that it will take for the first time full backup to fully transferred to the secondary side will be very long. Okay, so that is why we came up with this seed backup feature. With seed backup feature, basically for the first time backup, backup transmission from primary to secondary side, we can use a portable drive or a USB flash drive. To you can use the USB flash drive or portable disk. Just insert it to the primary aCloud cluster and export the first time full backup data. After that, you just take a taxi or drive your car to the secondary side with the portable disk. And then after you arrive in the secondary side, you just go there. There's no sound. So can everybody still hear my voice? Just give me a feedback if you can hear my voice. Because someone just, gave me the feedback that he cannot hear me. Can everybody hear my voice? Okay, great. So maybe that is, the network issue from that particular participant. Let's continue, okay? And like I said, the portable, the seed backup feature is used for data transmission for the first time backup for DR scenario, and it is particularly useful for customers who have a very narrow bandwidth between their primary side and the DR side, or customer has a very big data set for their first time full backup. Okay, and with this, there's no requirement for a very high bandwidth between primary and secondary side. They can use a portable disk to export their first time full backup data, and then they can transport that portable disk to the secondary side and import that first time full backup to the secondary side very easily, and it will be saving a lot of time for customer, and doesn't require them they build a high quality network bandwidth between the two sides. And of course, because this is a complementary feature for disaster recovery, so of course we're targeting customer who has disaster recovery requirement, and they have limited budget for their link construction between the two sides. Then seed backup will be a very good solution for the first time for backup data transmission. And like I said, there are a lot of optimizations and updates on the new version, making the aCloud 5.807 R1 and aCMP 5.806 R1 the most advanced and most powerful version we have ever designed so far. And there are some other features, and I'd like to go through them one by one for you guys. The first one, reporting, and this feature is implemented on aCMP 5.806 R1. It's implemented on the aCMP component, okay? But it doesn't require a license, all right? And with reporting feature, now users can export the reports based on their selections of VMs and based on their selected metrics like the CPU, RAM, IOPS latency, throughput of specified VMs and hosts. They can also design their own report template and generate the report based on the template they designed. The monitoring center will keep the running status of the VMs and the hosts as far back as 1 year, so they can have a 1 year of history for their VMs and hosts running status. This is a very good feature for auditing or reporting or briefing to the management about the running status of the workloads of the VMs on aCloud platform. And on the new version, we will also be supporting importing VMs in OVF, MF, and VMDK formats. Previously, we can only support OVA and VMA. And lots of partners and customers feedback to us that VMware no longer support exporting OVA format VMs, right? They can only export VMDK or OVF. So now on this version, we can support importing VMs in OVF and VMDK formats. And this is this will simplify the migration from other third-party virtualization platforms to SAN's aCloud platform. And we will also be supporting Italian keyboard for our Italian users, okay? And this feature is implemented on aCloud. To make stretched cluster solution available, we need to have the next feature, VM scheduling, affinity and anti-affinity. What does affinity and anti-affinity means? It means actually, you can basically specify a certain group of VMs running in a certain group of nodes. Okay, we have a concept of fault domain on this stretched cluster, and now to make sure that one fault domain dies, I can still have my workloads running on the other fault domain and have my data available on the other fault domain. I need to limit the running locations of my VMs, right? I need to limit some of the VMs, maybe they need to run together. They have to be run in the same group. Then I can just simply assign those VMs running in the same fault domain or in the same server, for better performance and lower latency. And also, on the contrary, I can also disallow VMs running side by side. For some VMs, maybe they have to be running on different fault domains or on different nodes. Examples are like Oracle Rack or the other clustered applications. For clustered applications, you have multiple instances running, to provide the services, to serve for your workloads, right? And those instances, they are not allowed to run in the same node or even in the same fault domain. So I can apply anti-affinity rule to those instances. With anti-affinity rule applied to those instances will be run in separate nodes or even in separate fault domains to isolate failure. And this is actually the technology that underpins our stretch cluster and our Oracle Rack support in the aCloud environment. And we can also support the last feature that is listed here, CPU and memory automated hot add for Windows Server 2012, 2012 R1 and 2016 VMs. This is like a catch up. This is something that we need to do to keep up with the latest versions of operating systems. And also on this version, we will support live migration for Linux VMs. Before, when we migrate, Linux operating system virtual machines or physical servers, you can only do the code migration. That means those servers have to be shut down and then migrated. With the live migration for Linux virtual machines and physical machines, now they can have a live migration, hot migration process. The impact on the business will be reduced to minimal. Okay, so basically those are all the updates and highlighted new features on the new version. The new version will be released by the end of this month. And when it is released, we will give you a notification and you can feel free to upgrade from your existing versions. So let's see whether or not you guys have any questions regarding the training content we provided today. So it seems like some of you have already brought up some questions in the chat box. Okay, let me go to the chat and see what questions you have come up with. Okay, so the site link is different place and the witness is same place, just the witness same place, just different floor. Yes, you can do that. You can deploy witness node on a separate floor. You can even in some extreme case, the customer doesn't have a separate floor or separate server room, they can even deploy witness node at the same side of their primary site. In that case, the reliability level will be a little bit lowered. And the next question is, for VGPU, if our customer using existing devices don't have VGPU, we can add? Yes, they can also do that. And most NVIDIA GPUs can support pass-through mode. So if they don't have VGPU, they don't want to buy license from NVIDIA. They just they have very few VMs that they need to use GPU resource. Then they can use GPU pass-through on aCloud. But the prerequisite is the GPU card, the graphic card must be from NVIDIA, because now we only support NVIDIA GPU. If we can add for this, we must buy the license or buy plugin and play. No, for GPU pass-through, customer doesn't need to buy anything. There's no license from NVIDIA or Sanford. Okay, they can use this GPU pass-through right away. We can set the sizing for VGPU. For example, we have specification VGPU 10 gig. We can size in some virtual. So basically, the GPU sizing will be largely influenced by the application's requirements. If customer has their existing GPU, then we can size the VGPU based on their existing GPU. And for most applications, they will have, those application vendors have specific recommended GPU specs for their applications. And when you look at the GPU, usually it depends on the GPU memory and the GPU, the number of the GPU processing cores. Will you send the slide of the webinar? Sure, we will upload the slide to community after the training. And for Windows 2019 operating system, you can install Windows 2019 now on aCloud, but it's not yet fully optimized. The fully optimized version will be coming in the middle of this year, okay? And we are currently optimizing the platform for Windows 2019. You can run Windows 2019 now, but it is not like fully optimized like Windows 2016. But the update for the optimization is coming soon. It's possible to have the PPT. Sure. Like I said, I will upload the PPT, the PowerPoint, the slides to our community so that you can download this material from the community portal. About backup, is it possible to use an ASV host as backup repository? Yes, it is possible. However, you have to install a file system to turn that ASV to turn that ASV host into a NFS file share server, or to provision iSCSI for the source VMs, for the source applications. Okay, it seems like there's no more questions from you guys. Okay, and if there's no more question, then let's call an end to this session. And we will, basically in the upcoming months, we will organize webinars every month with new features, new scenarios, or the contents you may feel like. And we'd like to hear suggestions or feedback from you, so that we can customize our training content to better accommodate your requirements, because all the webinars are centered around your requirements and your business. So we thank you for your participation in the survey, and let's keep in touch, and I look forward to seeing you next time on the webinar. Thank you.